Welcome to our exploration of angular kinematics in human movement. In this lecture, we'll dive into how angles are measured in biomechanics, focusing on the movement of body segments and joints. Understanding angular kinematics is crucial for analyzing human motion, whether in sports, rehabilitation, or daily activities. We'll begin by discussing the tools and methods used to measure angles, then move on to the concepts of anatomical position and segment orientation. By the end, you'll have a solid grasp of how professionals assess and interpret joint and segment angles in the human body. Measuring angles is fundamental in biomechanics because it allows us to quantify how the body moves. Whether you're a physical therapist, coach, or researcher, understanding joint angles helps in assessing performance, diagnosing issues, and tracking progress. Accurate measurement is essential for comparing movement patterns and ensuring effective interventions. In this scene, we'll see why precise angle measurement is the backbone of movement analysis and how it impacts both clinical and athletic settings. One of the primary tools for measuring joint angles is the goniometer. This simple yet effective instrument is widely used in clinical and research settings to assess the range of motion at various joints. By aligning the arms of the goniometer with the bones forming a joint, practitioners can read the angle directly. This process is vital for tracking changes over time, especially during rehabilitation or athletic training. Let's take a closer look at how a goniometer works and why it's so valuable in biomechanics. Joint angles are measured as the movement of a body segment away from the anatomical position. The anatomical position is a standardized posture where the body stands upright, facing forward with arms at the sides and palms facing forward. In this position, the angle at each joint is considered 0 degrees. As a segment moves away from this position, the angle increases, allowing us to quantify the amount of movement. This standardization ensures consistency when comparing measurements across individuals and sessions. Anatomical position serves as the reference point for all joint angle measurements. In this posture, the body is upright, feet together, arms at the sides, and palms facing forward. This universal starting point allows for clear and consistent communication among professionals. When a joint moves from this position, the angle formed is measured to determine the extent of movement. Understanding the anatomical position is essential for anyone studying or working in biomechanics. Angles are measured by observing the movement of a segment away from the anatomical position. For example, when you bend your elbow or knee, the angle increases from 0. The goniometer is placed so that its axis aligns with the joint and its arms follow the bones on either side. The resulting measurement gives a precise value for the joint's range of motion. This method is used for all major joints, including the shoulder, hip, knee, and elbow. Body segment orientation refers to the angular position of a body part relative to a fixed reference line, typically horizontal or vertical. For example, the orientation of the thigh or trunk can be described in relation to the ground. This concept is important for understanding how different parts of the body contribute to overall movement. By measuring segment orientation, we gain insights into posture, balance, and coordination during various activities. Angular orientation is the angle formed between a body segment and a fixed line of reference. This reference is usually either horizontal or vertical, depending on the movement being analyzed. For instance, the orientation of the trunk during a squat is measured relative to the horizontal. This measurement helps in evaluating movement efficiency and identifying abnormal patterns that may lead to injury or reduced performance. Let's consider a practical example, measuring the angle of orientation of the trunk and the angle of flexion at the knee. The trunk angle is measured with respect to the right horizontal, while the knee angle is measured from the anatomical position. These measurements are essential in activities like walking, running, or jumping, where both trunk and knee movement play significant roles. Accurate assessment helps in designing better training and rehabilitation programs. Flexion and extension are common movements measured in biomechanics. Flexion refers to decreasing the angle between two body segments, such as bending the elbow or knee. Extension is the opposite, increasing the angle back toward the anatomical position. These movements are fundamental in daily activities and sports, and their measurement provides valuable information about joint health and function. Standardizing how we measure and define angles ensures that results are reliable and comparable. Without standardization, it would be difficult to track progress or compare data between individuals and studies. Using the anatomical position and consistent reference lines allows professionals to communicate findings clearly and make informed decisions about treatment or training. Rehabilitation, measuring joint and segment angles is crucial for assessing patient progress. Therapists use goniometers to monitor improvements in range of motion after injuries or surgeries. By comparing measurements over time, they can adjust treatment plans and set realistic goals. Accurate angle measurement is key to successful recovery and return to normal function. Athletes and coaches rely on angle measurements to optimize performance. By analyzing joint and segment angles during specific movements, they can identify strengths and weaknesses, refine techniques, and prevent injuries. Whether it's a sprinter's knee angle at takeoff or a gymnast's trunk orientation during a flip, precise measurement is essential for reaching peak performance. While goniometers remain widely used, technology has introduced new ways to measure angles, such as motion capture systems and wearable sensors. These tools provide more detailed and dynamic data, allowing for real-time analysis of complex movements. As technology evolves, our ability to understand and improve human movement continues to grow. Wrap-up measuring angles is a cornerstone of biomechanics, providing essential information about joint and segment movement. Tools like the goniometer, along with standardized positions and reference lines, ensure accurate and meaningful analysis. Whether in clinical, athletic, or research settings, understanding angular kinematics helps us improve movement, prevent injury, and enhance performance. Keep these principles in mind as you continue your study of human biomechanics.